Hi everyone, my name is Cameron and today we're going to be looking at electrolysis. We're also going to be looking at how it can be used for aluminium extraction as well as electroplating. Now, this is quite a complicated topic for some students, but don't worry, I've got some really easy acronyms to remember. It takes a bit of practice, okay, so once you feel comfortable with this section, I suggest going and doing some questions that you can find on the website, on our website on Moodle, and get comfortable with it. Get comfortable with how they ask these questions and how you should answer them, what key points to be adding to your answers to get the maximum amount of marks. Okay, because when it comes to this section, it's really all the same stuff, no matter what example they're going to use. So if you can understand the main idea of electrolysis and use the key terms that they use, then you'll be totally fine for your exams. Okay, let's get started. Okay, so when it comes to electrolysis, it's important to understand this periodic table. I mentioned it in the previous videos. If you do not understand what ions are and how ions are formed, it will make electrolysis very difficult for you. I always tell my students it's not about remembering these things, it's about understanding them. If you understand them, you can apply that knowledge to any question. Okay, so let's go over this again. When it comes to the periodic table, okay, we know that, let me just get my laser pointer. Okay, we're going to have different groups. Okay, groups are going downwards. Now what these groups signify is how many electrons there are in the outer shell, in the outermost shell. Okay, now all elements, all atoms are trying to get a full outer shell. Okay, that can either be by losing the electrons in their outer shell so that they can be exposed to the full inner shell before, or it can be by gaining electrons to fill their outer shell. Okay, now groups 1, 2, the transition metals, and 3, okay, or you can say groups 1 to 13. It is easier for these atoms or these elements to lose electrons than it is for them to gain electrons. Okay, so they are going to form positive ions when they lose electrons. Okay, now depending on how many electrons they have in their outer shell will depend on what the charge will be, what the positive charge will be once they become an ion. Okay, and that's where we see this +1, +2. Metals can be different, so they can be +3 or +2, mostly +3, and then group 3 is going to be +3 as well. Okay. On the other hand, we're going to be looking at our groups that it's easier for them to gain electrons to make a full outer shell. Okay, and these are groups 4, 5, 6, and 7. Okay, so as they gain electrons, they're going to become negatively charged, therefore they're going to be negatively charged ions. Okay, so it's important to remember that when they are negatively charged ions, they're going to be anions. When they are positively charged ions, they're going to be cations. Okay, go over this slide again, rewatch this video if you don't quite understand what I just said. It is very important to understand this section before we move forward. Okay, so some of the key terms that we have to be able to use when we're talking about electrolysis is oxidation and reduction. Okay, the acronym that we're going to be using is oil rig. You remember that along with the pyramids that I told you, you'll be a-okay for these tests. Okay, when it comes to oil rigs, so we talked about certain elements that are going to more readily lose their electrons. If they lose their electrons, they become positive cations. Okay, so oil oxidation is loss. Okay, so if a metal has to lose its electrons and become a positively charged ion, it is being oxidized. If something is gaining electrons, okay, is going through reduction, because reduction is gain of electrons. It becomes an anion, it becomes negatively charged. So oil rig, oxidation is loss, reduction is gain. Okay, so let's look at what electrolysis is. So electrolysis is going to be the breakdown of ionic bonds, specifically ionic bonds, okay, using electricity. Okay, so the substance that's being broken down into its ions are going to be called an electrolyte. Okay, when we say we're using electricity, that means that this system requires a power source, so usually in the form of a battery. Okay, or an electrical power source. That's about it, just to have that movement of electrons, and we'll get to it now. Okay, so coming back to it, when we have a substance, an ionic substance, it is the bond between oppositely charged ions. Okay, so the charges are positive ions we're going to call cations. Okay, negatively charged ions we're going to call anions. Okay, now when it comes to the movement of those electrons, we talked in the previous slide about oil rig. Okay, oxidation, losing of electrons. Okay, and that is where it's going to take place. That oxidation, that losing of electrons, is going to take place at the positive anode. Okay, the negative cathode is where reduction is going to take place. So that is when they are gaining electrons. Okay, so anox, red cat. So we have oil rig, which is oxidation, is loss of electrons. This happens at the anode. Anox. Okay, reduction, this is the gaining of electrons, and it's going to happen at the cathode. Okay, cathode is going to be the negative cathode. Okay, and that's reduction, so the gaining of electrons at the negative cathode. Anox, red cat. Okay, that's the acronym you need to remember. So your positive ions are obviously going to then move towards your cathode. Your positive cations towards the negative cathode. Okay, your negative ions, your anions, are going to move to the anode, the positively charged electrode. I know that might be a little confusing. Okay, when we're talking about cations, cats are positive ions. Okay, while anonymous people are anions. Okay, they're negative. They will be attracted to the oppositely charged electrode. The two electrodes we have are the anode, which are going to attract anions. Anions are negative, therefore the anode is going to be positive. Okay, your cations are positively charged. They're going to be attracted to the negative electrode called the cathode. Okay, so just remember the charges of the ions, and then you'll know what the charge of the electrode is. Okay, luckily cathode, cation, anode, anion. Okay, and what electrolysis can be used for is for extracting metals. Okay, we're going to look at an example of that later, but it's going to be a lot cheaper than melting them down, okay, to refine these ores. Okay, so anox, red cat, oil rig. Okay, so here's an example of electrolysis. Okay, we're going to have the electrolyte being zinc chloride in a liquid form. Okay, remember it's important that if the electrolyte, being an ionic bond, it must be in a liquid or aqueous form. It must be either molten or it must be in an aqueous solution to be able to become an electrolyte. In a solid form, it will not electrolyze. Okay, so in this case, our chlorine is going to be our negative anion. It is attracted to the positive anode. Okay, or yeah, okay, and why is that? It's because it's going to give up its electrons, okay, to become chlorine by itself. So two chlorine molecules are going to give up their electrons to the anode. They're going to then bond together, and chlorine gas will then form around the anode. Okay, those electrons they gave up are going to travel up the anode to the battery. Okay, now that battery is providing a current, it's providing that force, it's pushing these electrons around. Okay, the battery is then going to supply the electrons at the cathode, the negative cathode, for the positive cations. Okay, these cations are going to accept these electrons and a zinc solid will form. Okay, because that zinc is going to be readily able to accept those electrons and become just zinc again. Okay. When we talk about these electrolysis reactions, they're also going to be asking you for the half equations. Okay, now what is the half equations? They're talking about the reduction and the oxidation equations. So if we're talking about a electrolyte, okay, what you have to see is, okay, so zinc is going to be positive, okay, and it's going to become zinc solid. Okay, just think. So to get from a positive to a neutral element, okay, it's going to have to gain 2 electrons. If it's gaining, that means it's reduction is happening. Okay, so this is the reduction half of the equation is Zn2 plus 2 electrons gives us a neutral zinc atom. Okay. Whereas chlorine, we know that it is going to be Cl minus, okay, because it is an anion, and that's going to have to, we can either say minus 1 electron to give us chlorine, or what you can say, instead of putting that electron here, you can also just go there plus 1 electron. Okay. I'm going to try and attempt an E. Let's see. Oh, I'm so good. Okay, so you can do it that way as well. You can go chlorine minus will then give us chlorine plus 1 electron because it has lost that electron. Okay. So one of the ways that electrolysis can be used is to extract these reactive metals from their ores. Okay, so when it comes to aluminium can be found in an ore called bauxite, okay, but when it is in that ore, it's found as aluminium oxide. So over many years, it has reacted with oxygen, okay, to form this molecule. But we don't want aluminium oxide, we want just aluminium, okay. So what we're going to do is we're going to take that aluminium oxide and we're going to electrolyze it, okay. So what's going to happen is aluminium, we know, is going to be a cation, okay, and therefore is going to be attracted to our cathode. Okay, when it is attracted to the cathode, it is going to gain electrons because the cathode is negatively charged. It's going to gain electrons and become neutral and solid aluminium. Okay, now where did that aluminium come from? It came from the aluminium oxide electrolyte. Okay, now aluminium oxide is an ionic bonded substance, okay, and therefore it needs to be molten down. Now it is a lot more efficient to perform this process in this manner when we are using something called cryolite. So cryolite is going to act as a sort of catalyst, and it's going to decrease the melting point of aluminium from 2050 degrees Celsius. So instead all we have to do is heat it to 850 degrees Celsius instead. Okay, this is obviously going to remain at a very high temperature as we put a lot of electricity into this process. Okay, so the cations, okay, are going to be the cation aluminium going to be attracted to the cathode. They're going to gain electrons from that cathode and they're going to become solid, okay, solid aluminium that can be collected. Now the other ion, the oxygen ion, okay, is going to be attracted to the anode, and this is where oxidation, oxidation at the anode, okay, anox is going to happen. So oxidation of oxygen, it's going to give up those 2 electrons to the anode, and that's then going to go back into the cell. Okay, whereas the aluminium is being reduced. What does it mean to be reduced? To gain electrons. Oil, rig. Okay, rig, reduction is gaining. And ox, red, cat, reduction is also going to be at the cathode. Okay, so go over those sort of acronyms, really try and understand what it is that is happening instead of trying to remember. Okay, and then I think you will be fine. And finally, we're going to be looking at the electrolysis of brine. Now, brine is a very salty liquid, okay, and the electrolysis of it is going to be producing chlorine gas, hydrogen gas, as well as sodium hydroxide. Okay, so how this works, we're going to have a sodium chloride in solution of water, okay. We're then going to electrolyze this. Now what this is going to do is it's going to break up the sodium chloride, okay. But what's going to happen here instead is the water is also electrolyzed. And therefore hydrogen, okay, being more reactive than the sodium, hydrogen is rather going to be attracted to the negative cathode, okay, to gain that electron. Okay, the hydroxide that is left from that H2O, okay, is then going to attach to the sodium. Okay, now why is that sodium there? It's because the chlorine was attracted from the sodium chloride to the anode, the positively charged anode, okay, to give up its electrons that it has because it's a negative ion and become chlorine gas. Okay, so nice and easy. The electrolyte is going to just break up, and usually it would be the sodium being attracted to the cathode, but in this case, when in a watery solution, it's going to be the water that will also be electrolyzed and split up. Okay, and instead that hydrogen gas is going to form, the sodium is going to be joined with the hydroxide that is left. Okay, so the half equations for this are going to be, as we can see over here. Okay, notice that even the half equations have to be balanced. So if we're going to have H2, hydrogen gas forming, it has to be H2, it's a diatomic molecule. Same thing with the chlorine. Okay, and if at the cathode, okay, we have reduction happening, that means it is gaining electrons to become neutral. Okay, whereas at the anode, oxidation is happening, oxidation is loss, and therefore chlorine is going to lose its 2 electrons. Okay, notice that it's 2 because there are 2 chlorines. Okay, and then that's going to then form chlorine gas. Okay, I hope this makes sense for you. If it doesn't, go back, watch it again, try apply it to some other examples, and if you still struggle, give us a call. I'll be here and you can book a lesson. Okay, my name's Cameron and I'll see you in the next lesson. Awkward.